Hi everybody, welcome back to the FPV drone racing course on Hacker.eu. My name is Ayan and I'm your course instructor. This is the class 3 of this course and today we are discussing about batteries, ESCs and motors. And we already had class 1 and 2 where we discussed about drone physics involved in flying, everything in between and propellers and frame selections. This is going to be a very crucial class because we are talking about the powerhouse of the drone and we will be discussing about motors, electronic speed controllers and batteries, and so that's a lot of things to cover today, so let's just dive right into the class. Alright, so this is the class agenda. Today we'll be talking about brushless DC motors, the one which we use in our drones, in our quadcopters, multi-rotors and any kind of UAVs. These are the most commonly used motors. We'll discuss about their parts and we'll discuss about magnetism, we'll discuss about electric field and motion and things like that, which you might have already studied in your high school or something, but we're gonna have a recap there because that's important to understand. Then we'll be talking about different ratings that a brushless motor have, and this is basically will help you choose a brushless motor for your drone project, because when you are going into the market you have a lot of different options available to suit your particular need, and you need to know about these ratings, and then only you will be able to pick the best motor for your project. Then we'll talk about the second part, that is the electronic speed controller and why it is required, what it does, and how to choose that, so what different rating it has. In the last part of the chapter we'll be talking about batteries, obviously the main power source of your drone or your UAVs. We'll be talking about different batteries options which are available in the market, and we'll talk about the ratings which it carries, and we'll touch upon the charging and storing of a battery a bit, but that comes later, and a short talk on safety if we still have the time. Okay, so this is how a typical brushless motor look, and you can see it has quite some parts. So this is the entire motor which is inside the metal casing. I'm gonna cut that open and I'll show you what inside that, but take a bird's eye look on this motor and take a look at specifically these numbers. So there are some numbers you can see, 22, 12, 13T, 1000 kV, something like that. So I'll be explaining these numbers, but for now just take a look at that. So this is the motor. It has 3 wires, and we'll also discuss that why it has 3 wires. This is nothing but a mounting plate. So if you are mounting it on a plane or a drone which is not following these hole patterns, then you can use that to mount. This is the main shaft which goes on top of this, and you put the propeller over here, and these are the mounting screws. So nothing fancy here, and I'll quickly move to the overhead cam and show you all the different kinds of brushless motor I'm having here. So these all are the brushless motor I'm having here. So you can see this is the smallest one I'm having here. So all these are brushless motor, but I just want you to look at how different they are from each other. All does same work. These all are motors, but every motor is different in terms of the configuration, in terms of size, and maybe some shape or whatnot, and also motors on my drone. So yes, these all are brushless motors, but every motor is different, so I just wanted you to take a look, and we'll touch upon that today. So this is how a brushless motor looks from inside. So basically there are 2 parts to any motor. One is the stationary part that stays on the frame, that stays on the body where you mount the motor, and other is the rotor, which is the part which rotates the motor, and which gives you the thrust if you couple it with a propeller, or which gives you some torque if you are coupling it with some gears or some mechanical assembly. So that's how a motor look, and I want you to look closely in this part and in this part. So you can see some copper coils going over here in the stator, and in the rotor you can see there are some permanent permanent magnets here. So this one rotor is carrying permanent magnets, and this one is carrying a coil, and on the coil there are 3 different wires. So we'll see how this works, but if we move to the overhead cam, I have also opened one of my motor to give you a closer look. So this is the motor which I opened, and you just need to remove that to get inside that. So this is the stator of the motor as as I showed in the PPT. This is the same thing happening over here with some copper coils wrapped around. This is a stationary part. You can see the motor bearing here, and this is the part which rotates, or it's called the rotor. and it has some magnets on the bell, the permanent magnets. So yes, these two comes together to form this brushless motor, and we have 3 wires here. So you can see two, but it has 3 wires. One of the wire was cut in a crash, so that's not an issue. So yes, that's how motor looks from inside, and today we're gonna talk about different kinds of motor. So let's start with different kinds of motor, and the first category we have when we talk about BLDC motor or a brushless DC motor is Inrunner and Outrunner. So basically, these two are the types of brushless DC motor, and they both have their own specific application. So I want you to focus on the image on the right hand side first. So you can see on the Inrunner motor, the magnets, the permanent magnets are on the inside, while the electromagnets are on the outside. While on the Outrunner motor, which I just showed you, the permanent magnets are on the rotor, the rotating part, while the electromagnets, the coils are on the inside, on the stator, that is the stationary part. So that is the major difference between an Inrunner motor and the Outrunner motor. The positions of permanent magnets and the electromagnets are different in Inrunner and Outrunner, and because of that they have different capabilities, they have different applications. And on the left hand side you can see on the top you have an Outrunner motor which I just showed you, and on the below you see an Inrunner motor which I don't have with me personally, but these kinds of motor are really common in drill machines and in some fans, these kinds of stuff. So these kinds of motor you will generally find there, while these kinds of motor you will find on your drones and UAVs and RC airplanes and whatnot. So on this motor the entire body of this motor rotates, while in the Inrunner motor only this particular shaft area rotates. So that also is kind of a difference between these two motors. So both can be used interchangeably, but it is having some different properties, like Inrunner motor gives you more torque compared to the Outrunner motor, but when coupled with a propeller, Outrunner motor will give you more thrust. So things like that, I'm not going very much into details because we need to focus on the Outrunner motor bus. But just for your knowledge, you should know that you also have an option to run an Inrunner motor where only the shaft rotates, and maybe in some applications other than drones, these motor comes handy. So this is also another kind of motor which we used in indoor drones specifically. So these are not brushless DC motor. As you can see, they don't have 3 wires going at the back. They just have 2 wires. So it can be directly driven with a battery without the need of electronic speed controller. You can control using any driver basically the speed of this motor. So they are called Coreless DC motor. They can run at a very high RPM and mainly used for indoor drones. They don't particularly have a good lifespan or longevity, but that is not an issue in indoor drones, and they are really cheap, so you can replace them easily. So just for your knowledge, there also exists this Coreless DC motor which you can also use in your drone project. More specifically for smaller indoor drones, they are being used. So this is an interesting slide, and this is where the actual fun begins. So I wanted to touch a bit about electric field, magnetic field and motion, and this is the concept which you might have also studied in your high school maybe, or in your university, or a grad school if you are from an engineering background or something similar. So basically there is a relation between these three: the electric field, the magnetic field and the motion. And you might remember from the high school the Fleming's left hand right hand rule, these kinds of things. So they actually tell the relationship between these three entities. So basically, in a nutshell, the rule of thumb is if you have electric field and magnetic field, you can get motion. If you have motion and electric field, then you can get an electric field. So that is the entire idea behind motors and generators. In case of motors, you have electric field, you have a magnetic field, you get the motion. While in case of generator, you have motion, you have magnetic field and you get electric field. So generator gives you electricity while motor takes the electricity and gives you motion. So I'm gonna do a small experiment here and move to the overhead camera. So this is a small DC motor which I'm having. So everybody knows how a motor works. So these having two terminals, you just need to provide the electric current or electric voltage potential over here, and it will start rotating. So that is not an experiment today. Everyone can do that. Everyone has done that. What I want to show you is that this motor can also act as a generator. And what I mean by that is, we know that this motor has some magnets built in. We are providing electricity and it gives you motion. But because it already has magnet inside, if we are providing some motion, then it should act as a generator and give us electricity. So that is what we are going to experiment today. So I have a small LED with me here. So let's see if I can show you here. So I'm gonna connect my LED to the terminals. I'm gonna just put my hands here and see if that works. So I've connected LED on the terminals of this motor. So if the connection is good and I rotate that, you can see LED should shine. So let's make the connection first. I should have done with the wires, but there you go. So you can see as I'm rotating the motor, you are seeing the LED is blinking. So what's happening here is, as I mentioned, we have magnets here. So we have a magnetic field and we are providing motion. So magnetic field and motions give you electric field. So that is exactly what is happening here. So this is a small experiment which you can do, and this proves that motor can also act as a generator. So that is the entire relationship between these three entities, so to speak. So in case of motor on the left, you can see that this is called an armature in case of DC motors. We have different nomenclature when it comes to AC and DC, and I'll touch upon that in later slides. So this is the coil which carries the current, and current is coming from this battery. So this is carrying the current. This is having an electric field, and here you can see permanent magnets, the North Pole and the South Pole. So because we have electric field, we have magnetic field, this armature will start rotating. So this is the motion which you are getting. Similarly, in case of a generator, your coil is already rotating, you have the magnetic field, so across the coil you will get some electric field, and you can connect a voltmeter here and you can check that you are getting some voltage out of it. So that is the relationship between electric field, magnetic field and motion. And this relationship says universal for whatever you are looking at. Maybe it's a DC motor or single phase AC motor or three-phase AC motor or synchronous motor. This concept does not change. Maybe the nature of magnetic field changes, maybe the nature of electric field changes, or the direction of motion changes, but overall this concept remains same throughout, irrespective of you are working on DC or AC or single phase or three phase or multi-phase or whatever. But that is the basic thing I wanted you to clear before moving ahead. Alright, so moving ahead, let's talk about some questions that you might be having, because I know from my previous workshop a lot of my students have these questions, and it could be as simple as why this motor has 3 wires, because all the motors that we generally see, they have 2 wires. You provide a current across these 2 wires and the motor start rotating. Then why this brushless motor has 3 wires? And you might be having some question like, what exactly is a brush and why we are talking about brushes and brushless, and what exactly are those things? So let's talk about how a motor works. So I told you that in case of a motor, we have a permanent magnets which provides a magnetic field. We provide the electric current across the coil that creates an electric field, and because of that electric field and magnetic field, we get some motion. But how exactly are we getting in motion? So what exactly happening is, we are changing the electric field, and let's see this diagram on the left. So this is North Pole and this is South Pole. And you also know that because of electric field, a magnetic field is also gets generated. So we are providing an electric field, and this act as an electromagnet because this is a coil. Now let's say the current is flowing from this direction, and this part of the coil becomes north. So north and north will repel each other, and this will come into this side. Now what we are doing, we are changing the polarity of this. Now as soon as the north comes here, this will become south, and the south and south will repel, and this keeps on rotating and you'll get the motion. That is how a motor exactly works, by alternating the voltage between the coil. Now the question is, how are we alternating the voltage? Because we are using a battery, and battery is a DC source. It has a fixed source. So in case of brushed DC motor, the answer lies in this part. So this is called a commutator. So commutator is nothing. So for now, just understand that commutator is a small component of a motor that helps in alternating the input source of electric field. So that's all. Now, what is the role of brushes? So when the coil is rotating, you still need to keep provide the electric field. So that is where the brushes comes into the handy. So brushes are nothing but small wires of carbon generally, and they are conductive in nature. So these are helps in keep continuously providing the electric field to the coil even when it's rotating. That is exactly also becomes a drawback of brush DC motor, because what is having is contact between the brushes and the coils, and because of this contact there would be a friction when the coil is rotating, and because of this friction a lot of heat will be generated. So what I'm trying to say is that these brushes are not very efficient. These are the mechanical assembly. They have a contact, they have a friction. A lot of power is being wasted into heat over the time, and because of the mechanical assembly, they also are prone to wear and tear. So that is why brushes are not very efficient. They don't have a much life. So that is why brush motors are not useful for something like drones, where we need good performance, where we need good efficiency, where we need lot of input power converted into output power, and there is less wastage, less friction, less heat. That is why we come to something called brushless motor. So as you can see on the right, we have a brushless motor, and instead of two coils as in case of brush motor, we have three coils here, and we are alternating these current in this coil. So basically what is happening, we are providing a three-phase AC source in the brushless motor instead of a DC source. And the property of three-phase AC source is it has a rotating magnetic field, so it keeps on rotating, and the permanent magnets are here. So because of this relative rotation of electric field and coming in contact with the magnetic field, we get the continuous motion. So as you can see, there is no physical contact between the rotor and the stator, or there is no brush assembly. Brushless motors are very efficient, they are very powerful, they are not prone to friction losses or heat losses, and there is no mechanical assembly, so there is very less wear and tear. So that is the reason we use brushless motor for something like drone, where we need very high efficiency, very high performances. So this also explains why it has three wires. So basically we are having three coils, and we are providing a three-phase voltage source. That is why we need three wires. Now the question which can arise is, where are we getting the three-phase source, because we are using a battery, and that is why electronic speed controller comes in handy. So electronic speed controller, what they are doing, they are taking a battery source, a DC source, and converting it into a three-phase AC source. So they are doing something which is called inversion or inverter, as we use in our homes to convert DC to AC sometimes, especially in India. So ESC is nothing but an inverter, and while doing that, it can also regulate how much voltage to supply to each coil, and based on that they can control the speed. So we'll discuss more in the ESC chapter, but for now let's move to the motor ratings. So when you go out to the market to buy a brushless DC motor for your next drone project, you will be overwhelmed to see all kind of numbers the motors are associated with, and they can be very confusing, and that is what we are here for, and we are discussing the motor ratings. So as I told that if you cut open this motor from the gut, you'll see you have a stator and you have a rotor. A rotor is generally, in case of drone community, is also known as the motor bell, which carries the permanent magnets, and this stator, which has the electromagnets or the coils, are sometimes referred as the motor base. This is the one which we mount on the drone, and of course we need both to work, but I wanted to specifically focus you onto the stator side, because these are the things on the left, the stator, which drastically changes the motor behavior, which drastically changes the motor performances. And what I mean by that is I want you to focus on these numbers. So when you go and you want to buy a motor for your drone project, you will be presented by these kinds of numbers. So a manufacturer may refer it as 2306 2300 kV motor. So what exactly is this number, and what should we conclude with this number? So a motor rating is divided into three parts, and as I am showing on the screen, so the first two numbers is nothing but the width of the stator in millimeter. The second set of number is nothing but the length of the stator in millimeter, and I want you to focus only on these two numbers for now. So this is the stator, and if I go to this motor, so this is the stator over here, and this is the entire width of the stator, and this is the length of the stator. And if I look at this motor bell, it is written 2208, so that means that the stator is 22 millimeter in width and 8 millimeter in height. So similarly on the slide, if you are seeing this number 2306 for this motor, it means that this motor is 23 millimeter wide in terms of the stator and 6 millimeter length in terms of the stator length. So that is the stator height and that is the stator width, only the part which has the coils, which has the electromagnet. So why these numbers matter? Because these numbers define the performance of this motor, and what I mean by that is more the width of the stator, more torque your motor provides at lower RPM. More the length of the stator, more power it provides at higher RPM. So that is a simple fundamental to explain these numbers. So if you have a wider stator, basically you are having more metal going into that. Basically you will be having more coil going into that, and because of that you'll get more torque at lower RPM. That is, if you are flying, let's say 20% throttle or 30% throttle, then you will get more torque. And torque is necessary because initially when you are taking off the drone, you need a higher torque to rotate the propeller and to take off. But at higher RPM, for example, if you are flying in a drone racing competition where you need more power, then you need to go for a motor that is having a higher stator length. For example, this motor is having 6 millimeter of stator length, while the motor which I showed you in the overhead camera having 8 millimeter of stator length. So that motor will provide me more power at higher RPM, like 70% or 80% throttle. But this motor is having 23 millimeter of stator width, and that one is having 22 millimeter of stator width. So this one on the screen will provide me more torque at lower RPM. So I am able to spin heavier propeller on this motor very easily, because this motor is having more torque, and this would be able to rotate heavier propeller compared to the motor which is having less torque. And because of those heavy propeller, they will also give me more thrust and so on. But as I already mentioned in both of the previous classes, everything in case of building drones is about trade-off. You gain something, you lose another things, and same is true for motor as well. So you can buy a motor which is having a good stator length or a good stator width, which has more torque at lower RPM, which has very high power at higher RPM. But what you will lose? Obviously, you will lose your flight time, because of more power it will consume more current. You will get less flight time. So you need to find a sweet spot, and everything in drone is about finding the sweet spot. So that is why there are some certain numbers which you need to keep in mind. So I'm gonna discuss that in the next slide, hopefully, where I'll show you some common motors which are used for drone racing, FPV drone freestyle, and some motors which are used for bigger drones like 450 size drones, which are used for aerial cinematography and whatnot. So these are the two numbers, and I want you to keep that in mind. Apart from that, there is a third number which is associated with the motor, and that is the kV rating of the motor. And it is not kilovolt, as confused by a lot of the people listening to this first time. kV stands for RPM per volt, that is revolutions per minute per volt. So in case of this motor is having 2300 kV. That means this motor can revolve 2300 revolutions in 1 minute on 1 volt. So you can do the maths, and we fly with a battery of 12 volt, 16 volt, 22 volts, and you multiply with that. That is the total RPM this motor can rotate. So if you talk about, I've given a simple calculation to make things simple. So I'll go back to the overhead camera one more time. So all these motors has a different RPM, different kV rating. So if I talk about this motor, this one is having 2280 kV. If I talk about this motor is having 2600 kV. This motor is having 1800 kV, and this motor is having 1000 kV. So we have a formula for 1000 kV, and if I rotate this motor at, let's say, 12 volt or a 3 cell battery, then 1000 into 12 volt will give you 12,000 revolutions per minute. So that is the idea behind kV rating, RPM per volt. Now, one thing you can conclude from here is, as I already mentioned, that there is not one motor which is fit for you. Depending on what you need your drone to be, the thrust to weight ratio you need, as we discussed in the last class and the class before that, how much thrust you need, how much weight your drone is carrying. Based on that, you need to pick your motor and propeller. So what I mean by that is, let's say you want a smaller drone which can spin a 4 or 5 inch propeller, but you want a 1 kg thrust. So you need a smaller motor which with very high RPM. You cannot go low on RPM, because you want your motor to spin at a very high RPM. Only then you will be able to get adequate thrust for a smaller propeller. Now let's say you have a bigger frame and you are able to fly a big propeller, let's say a 10 inch propeller or 12 inch propeller. Then you need to go for a lower kV motor or a lower RPM motor, because if you are spinning a bigger propeller with a very high RPM motor, then bigger propeller, very high RPM will produce lot of air resistance and your motor will burn out. So in that case, you need to go for a lower RPM motor if you are running a bigger propeller. So rule of thumb is, the bigger the propeller, the less RPM you need to get equal amount of thrust. So let's say you need 1 kg of thrust from a smaller motor. Then you need smaller motor, high RPM. You need same 1 kg of thrust with bigger propeller, 10 inch propeller. Then you need a smaller RPM motor. So that is how we do mix and match things, we adjust things, and that is how we come up with the different drone frames having different kinds of motors. So as I mentioned, these are the typical motor ratings. So if you want to build a mini quad like this one, which can spin a propeller 4 to 6 inches, then the common sizes available are 2204, 2205, and make sure the first set of number is the width of the stator in millimeter. The second set is the length of the stator in millimeter. So 2204 means 22 millimeter width and 4 millimeter height. So 2204, 2205, 2206, 2207, 2305, 2306, 2307. These are the common motors for a 4 to 6 inch propeller. And in terms of kV, you have 1750 kV, you have 2000 kV, 2300 and 2600. So again, kV stands for RPM per volt. So if you are running a battery with the higher voltage, let's say you are running a 6 cell battery with 22 volts, then you need a lower kV motor, lower RPM motor, because effectively when you multiply a smaller number with a bigger number, it will get a bigger number. And in the same way, you need a 2600 kV if you are, let's say, running a 3 cell battery or 12 volts battery. Then a bigger number multiplied with a smaller number, you'll get the adequate amount of thrust. And I hope I'm able to make things clear by that. So everything is a mix and match and finding that sweet spot in terms of drone. Talking about this drone, is also a very common drone people make, a 450 size quadcopter. The common motor which are available in the market are 2212, 2214, 2412, these kinds of motors. So I'm also having one motor over here. So this is the one I used to make bigger quads. And if I talk about this rating, it's 2213, 935 kV. So you can see the difference. So this one is 2213, 930 kV, and this one is 22.5, 2600 kV. So both of motor provides 1 kg of thrust, but this require 5 inch propeller for 1 kg of thrust, and this require 10 inch propeller for 1 kg of thrust. So that is about finding the sweet spot in terms of motor. So we talked about how the length and width of the stator determines the motor performance, but are there anything else that can impact the motor performance? And the answer is simply yes. So every component of this motor can impact the motor performance, whether it is the shaft, the bearing, the windings, everything, even the quality of the magnet used. So This is how a general brushless DC motor look, and in the drone community we call this the motor bell, which has the permanent magnets. This is the shaft which rests on the stator, and this also has the propeller on the other side. This is the stator, which has the coil carrying three-phase AC current, and this is a bearing on which the rotor rotates. So this bearing can be made of ceramic or some other metals, and everything will determine the motor performance. And more specifically, these electromagnets and these magnets, these are the parts which determines the motor performance a lot, apart from the stator width and the height, of course, which we already discussed. So these are nothing but the copper winding around the stator, and the number of turns, the gauge of the wire used, the quality of this wire used, the total number of electromagnets, and what are the quality of these magnets. They together determine the motor performance, and they are called poles and the magnets. So the poles are the electromagnet part which are on the stator, and the magnets are the part of the rotor which is on the bell. So depending on how much poles and how much magnets a motor is having, the performance of motor changes. And the general rule of thumb is more number of poles, that is more number of electromagnets the motor is having, the smoother will be the motor. And the less number of poles the motor is having, the powerful will be the motor. So again, you see a trade-off. So you want a smoother motor, so your drone performs very smooth in the air, the drone is stable. But if you keep adding poles, then you will keep losing power. So you need to find a sweet spot. And generally speaking, if you talk about FPV drone racing, 12 poles or 14 poles, these are the common number of poles which you will find on the stator. And sometimes you can also look into the specifications of motor manufacturer, and you will find 12N14P. And what it means, it has 12 electromagnets and 14 permanent magnets. And again, electromagnets are nothing but the coil on the stator, and permanent magnets are nothing but these magnets on the rotor. And again, more number of poles you have, more smooth will be the motor. Fewer poles you have, the powerful will be the motor. And over the period of time, since I first started making drones and planes, the motor has evolved a lot. And based on these factors, like what kind of wire you has used, how many turns each pole is having, what is the gauge of this wire, what is the quality of this wire, what is the amount of gap between permanent magnets and electromagnets. So this is called an air gap. So you want this gap to be minimum, but of course it cannot be zero, otherwise your motor will not rotate. There has to be some gap. So what manufacturers are doing, they have come up with something called curved magnets. So these magnets you are seeing, they are basically rectangular, but now they started making curved magnets. So you have very less air gap between your rotor and the stator. So again, everything impacts the performance. And what are magnet heat capabilities? So there is something which is called demagnetization. So at higher temperature, the magnet start losing its magnetism, and that is very common in permanent magnets. So because of extensive flying, this motor can get hot, and these magnets can demagnetize themselves. So that is why manufacturers are using very high heat capability magnets. So your motor performs a linear performance even at a very high speed or a very hot day. So that is the technology which is being evolved, and it's true for every new field. So new things are coming every day. Stator lamination is this material on the side. This is being laminated by some materials, I'm not really sure what. So this bearing is made of ceramic or metal, and new motors they call ceramic Japanese bearing. And the balance of this bell, that means each magnet is having same weight, so it's perfectly balanced. So what I mean by all these things is manufacturers needs to keep in mind to give you the best motor out of their offerings. But we do not need to worry that much about it. We just need to worry about the width, the height, maybe number of poles and magnets. But these things we should leave on manufacturer. But this is good to know that air gaps and what magnets are using and what lamination they are using, they all affect the motor performance. And if we are someone who is not making a motor, then we can definitely skip these parts. And I have mentioned this link here. So Oscar is a great blogger on drones, and you can find more about all this stuff on this link. So feel free to visit and learn from there. Alright, so moving ahead to the second part of this chapter, that is the electronic speed controller. So this is how an electronic speed controller looks like, and I have some with me on the overhead camera. So this is like the one which you are seeing on the screen as well. Here we go, and this is the same one, I believe, and this is another electronic speed controller. There are some others, so it comes in all shapes and sizes and configuration. And this is another interesting electronic speed controller. It's a 4-in-1, because we have 4 motors, we need to use 4 electronic speed controllers. So instead of using 4 different electronic speed controller, you can use a 4-in-1. This sits on top of your flight controller and communicate directly. So all kinds of things are available in the market these days. So what is the main role of an electronic speed controller? It's nothing but, as I mentioned, that the BLDC motor, it's actually a 3-phase AC motor. So the battery is supplying a DC current, your motor needs a 3-phase AC current. This conversion is being done by the electronic speed controller. So here you can see electronic speed controller has the 3 wires which connects to your motor for each coil for 3-phase motor. Here you have 2 wires, this connect to the battery, the positive and the negative, and this is another wire which is called a signal wire. It connects to your flight controller, and your flight controller will tell at what speed I want you to spin the motor, at how much RPM I need electronic speed controller to spin a motor. And that is the basic fundamental behind the drone. The flight controller takes input from the user. The flight controller translates that into the RPM for each motor, and the RPM is being controlled by electronic speed controller. So electronic speed controller does 2 parts. Number 1, conversion from DC to 3-phase AC. Number 2, control the speed by taking input from a flight controller. In case of plane where there is no flight controller, in case of RC plane, then this signal wire connects directly to the receiver on the throttle channel, and on the value of throttle is being sent by the user, and the speed of the motor, the RPM of the motor, is being controlled by this ESC. So when we talk about ESC, it also has some ratings beyond which you cannot go. So it has a voltage rating and a current rating. Voltage rating is the maximum voltage an ESC can handle, and the current rating is the maximum current an ESC can handle. And if you give more voltage, if you give more current, you will destroy your ESC. They will burn. So never exceed this voltage and current rating, and these are mentioned by the manufacturer, and mostly these are mentioned on the ESC itself. So if I talk about this ESC, it's a 30 amp ESC, and it says 2 to 4S. So that means I can use a 2 cell to 4 cell battery maximum, and it is a 30 ampere ESC. So this ESC cannot supply greater than 30 ampere of current. So what I mean by that is, if you connect this ESC to this motor and you are rotating a 5-inch propeller, make sure that this motor and that propeller is not taking more than 30 amperes, because this ESC has a limitation of 30 ampere. And if this motor and propeller takes more than 30 ampere, then you will destroy this ESC, you will burn this ESC. So make sure to never go beyond the current limit. And the voltage limit is nothing but what battery I can apply to it. So this is saying 2 to 4S, so I can apply a maximum 4 cell battery, and I cannot go beyond 4 cell battery. So if you want to use a 22 volt system or a 6 cell battery, you cannot use this ESC. Then you need to go for something like a 6 cell ESC, something like that. So this ESC can support up to 6 cell. So you need to figure your system out. And this is the basic connection. So this one goes to the battery, this one goes to the motor, and this one goes to the flight controller, the signal wire. And every motor needs one ESC to rotate. So if you are making a quadcopter with the 4 motors, you need 4 ESCs. And one last thing, there is a burst current rating these days in ESC, and what it means that for some time it can go beyond its current limit. So let's say your ESC has a normal current rating of 30 amperes and a burst current rating of 50 amperes. So for 5 to 10 seconds your ESC can handle 50 amperes, but not more than that time period. And why it is important is sometimes you are racing and you are on the last lap and you just need full power you have, and that is where the burst current ratings comes handy. So you can give full throttle for 5 to 10 seconds and you will not harm your ESC. So that is a good thing there. So ESCs, they have a small microcontroller which runs a firmware, which runs a piece of software. And what this piece of software is doing, it is so this is a signal wire, and it gets a signal from receiver and flight controller. And to understand this signal, the processor on this ESC that works on a listening protocol. So ESC and flight controller, they agree that they will speak a common protocol. So flight controller sending the signal in terms of zeros and one, or in terms of analog pulses, and that microcontroller will read that pulses or the bit stream of zeros and one, and it will understand how much RPM I need to rotate my motor as requested by the flight controller. So that is why the ESC needs a software to understand the signal. And you can definitely write your own program for the ESC on firmware for this ESC, but there are some firmwares already open source available. And by the way, your ESC comes already flashed with some firmware. So when you buy an ESC, you do not need to worry what firmware you want to flash. It comes already with a firmware. But definitely, if you are making your own ESC, which is absolutely possible, then you can use these open source firmware like BL Heli, BL Heli S, and BL Heli 32. So these are kind of firmware which are available in the open source community. Simon K is also a firmware which is very old, not used anymore. And there are also some closed source firmware which are proprietary to some company like KISS and Gemfan. So BLLE I know is one of the open source widely used widely used firmware for ESCs used by all major drone pilots, especially in the FPV community. Simon K is quite old, and this ESC runs Simon K out of the box, but new ESCs which we are using in drone racing uses BL Heli or BL Heli S or BL Heli 32. So a major difference in these firmware is the BL Heli supports regenerative braking. That is, for example, in case of plane, you want your motor to slow down very slowly. Because your plane can soar, your plane has an airfoil which will keep it in air without any power, so it can do some soaring, it can do some gliding. But in case of drone, you need very precise control, so you want your motor to come stop as soon as you cut the throttle. So this facility is available in BL Heli firmware. It's called active braking or regenerative braking. So that's the major difference. By the way, no one uses Simon K anymore. It's quite old. So make sure if you're buying ESC for drone racing, you go for BL Heli S or BL Heli 32. These are the latest firmware for your ESCs. Okay, so moving ahead, as I mentioned that the function of the ESC is to control the motor speed and how much RPM ESC wants to rotate the motor. That depends on the signal coming from the flight controller. So there needs to be a protocol that is understood by flight controller as well as your ESC. So ESC communicates with your receiver or flight controller to get desired value of motor RPM. So as I mentioned, ESC can connect to a receiver or a flight controller, and the receiver and flight controller will tell how much RPM ESC should rotate the motor at. And the communication can follow a standard. So there are some industry standards already which can follow by these communications. So one of them is called PWM or pulse width modulation. So it's like pulses of on and off, and based on how much pulse is on, you get the duty cycle and things like that. You don't need to get into very much details. You just need to understand that there is one protocol that ESC and flight controller both should speak the same protocol, and then only they can communicate. So as the drone industry progresses, as more faster and faster equipment start coming, PWM gets outdated because it's very slow, and the new protocol which came, it's one shot 125. It's also very old now, but when we started drone racing, that is like the fastest protocol available. Then came the one shot 42. Nowadays, the most common protocol that everyone is using is either D-shot or multi-shot. So difference between multi-shot and D-shot is D-shot is a digital protocol. That means it is in form of zeros and one. So flight controller sends zeros and ones to ESC, and ESC understand how much RPM flight controller wants my motor to be revolved. Multi-shot is an analog protocol. That means it is sending again the analog pulses, and ESC needs to calculate at ESC and how much RPM it needs to be sent. So D-shot is of course the fastest, the digital, the most reliable protocol. But if you want analog protocol and you want the fastest, multi-shot is the option, and it uses something called DMA, or direct memory access. So if you are someone from embedded background, you know that DMA is a peripheral that you can use to do a lot of data transaction in a very less time. So these are all the protocols, and if you're not programming yourself, you just need to select the right protocol when you're programming your flight controller and your ESC, and you are good to go. So this is a small comparison between the time. So you can see that one shot 125 takes the largest, take the maximum time. So it takes around 250 millisecond for one signal to come from flight controller to ESC, while D-shot 1200 is the fastest protocol. It takes very less time for communication. So if you are buying an ESC for drone racing, for drone freestyle, FPV, go for D-shot 1200. These are expensive, but these are really worth the price. So as I mentioned, modernization has hit the drone after FPV has become mainstream, and lot of different companies, they have did some R&D, and they come up with new things in the ESC. And what modernization has hit the ESC. So first of all, this ESC used an 8-bit processor, or a small AVR kind of microcontroller, which are generally 8-bit. But the modern ESCs, they are using 32-bit processor or ARM processor. These are very fast, these are reliable, have more space. So 32-bit processor are generally way to go ahead. And BLDC32 firmware, which I mentioned, that is specifically for 32-bit ESCs. And I already mentioned that they support high speed precise timing. So they support protocols like D-shot 1200 or multi-shot. These are very high speed. And of course, digital protocols are a way to go. Because if we are sending an analog signal like this, so this is a PWM signal. So if this signal is being sent by flight controller to this ESC needs to do calculation based on what is the on time, what is the off time, and then calculate how much RPM is being requested. And this takes a lot of time. Doing the calculation, and you are flying drone at 100 miles per hour. You need very fast processing time. So this is not a way to go. The way to go is digital. You just tell your ESC, I want my motor to be at 33% RPM, and it understands quickly and it does. So that is only possible if you are communicating over digital. So both systems are digital. Flight controller is digital, ESC is digital, but why should they are speaking analog? So yes, digital protocols are the way to go. As I already mentioned, regenerative braking is there. So these ESCs has the capability to brake the motor, and I don't mean to brake the motor, I mean the braking, like braking in your cars. So these motors can stop these ESCs can stop the motor whenever is needed for from the user and things like that. Software reversing. So initially in the days, so this ESC is having 3 wires, motor has 3 wires. If you connect these 3 wires to the motor, it will rotate in one direction, let's say clockwise. If you want your motor to rotate anti-clockwise, you need to switch any 2 wires, and you need to interchange any 2 wires. But nowadays you can directly plug these 3 wires to the motor, and you can do reversing on the software. And because of that, you can do reversing in between the flight. So you can change the direction of motor in between the flights, and that opens the door for something called 3D FPV, where you can fly upside down. And I'll show in some later chapters what is a 3D FPV. But for now, just understand that changing the motor direction using software is very much possible because of modern ESCs. There is something called calibration which is required. So when we were talking about analog protocols, ESC needs to be calibrated. ESC should know what is the maximum range of throttle, what is the minimum range of throttle. That is something called calibration, and when we move to the flight controller chapter, we'll see how to calibrate the ESC. But because of digital protocols, there is no calibration needed. Just there are zeros and ones, and you can get away with the calibration. So that is a really good thing that has happened. So that is what I mentioned. So before the software reversing was possible, if you are connected this ESC to your motor and it's spinning in a clockwise direction and you want to reverse the direction, then you need to change any two wires like this. So you change any two wires and it rotates anti-clockwise. It is still true in these ESCs, but nowadays we generally prefer doing it with software. So you just flick one switch on the software and you are good to go. And the best part is you can do it in flight. Alright, so moving ahead to the last part of the chapter, that is about the battery. So battery again is the powerhouse of your drone, and this is the main source of the power for the entire drone system, and that's how a typical battery looks like. And I'll also show you the battery which I use on the overhead camera. So this is a typical battery. This has this lead which is the main lead, and this has something called a balance port, and we'll discuss about that. So typically speaking, in case of drones, we used these kinds of batteries. So LiPo or lithium polymer, Li-ion or lithium ion, Li-Fe or lithium iron, Li-HV or lithium high voltage. So these are the common batteries which are used in drones. So lithium polymer battery is the most common and most easily available battery for drones, and it has 4.2 voltage each cell at full charge. Same with the lithium ion. Lithium ion is less preferred compared to lithium polymer, but because it's quite expensive, but it has same cell voltage. Then there are some new batteries which are being adopted in the drone community. So LiFe is another one. It has some iron additives with lithium. And a new battery which is getting mainstream is Li-HV or lithium high voltage, and as the name suggests, the per cell voltage at full charge is 4.35 volt. And remember when I talked about the motor kV rating, and the RPM depends on the voltage. So imagine the Li-HV battery will give you more RPM, slightly more RPM because of the more voltage. So this is are the common cells which are used to make batteries for drones. And yes, each cell is having some voltage, and when you combine these cells together, they form a battery. So on the right you can see, I think it's a 3-cell battery. Yes, it's a 3-cell battery, it's mentioned here, and it's also mentioned 11.1 volt. It's not the full charge voltage, because at full charge it comes around 12.5 volt, and it has its own rating which we are gonna discuss shortly. One thing before that, it's nanotech. So nanotech is a new nanotechnology which is being coming in the battery, and they are making battery more stable, more reliable. And I'm not expert of nanotechnology, so I'm just leaving this term to you to research ahead. So nanotech is another technology which is being added to these to make new batteries in drones. So these are the battery ratings. So if you see on this battery, it says 1800 mAh 75C. So these are the common kinds of numbers which you see on a battery. And similarly you see 4S 2200 mAh 60C. So what exactly are these numbers? So the first number, the S rating, it's the number of cells in a battery. So in a 4S, the number of cells is a 4 cells battery. So a 4S is a 4-cell battery, a 6S is a 6-cell battery. I know that it should be C, but it's S in this case. So make sure not to confuse with that, because C is different. So if I tell you 3S, I have a 3S battery, I mean to say that my battery has a 3-cell, and each cell has a voltage, so it will give a combined voltage of multiplied by 3. The second rating, it's called the mAh rating, or this is also known as the battery capacity. How much the capacity is this battery is having. So a 2200 mAh battery has more capacity compared to the 1800 mAh battery. So this will give you more flight time. So make sure to check the mAh rating before buying a battery. The last rating is called C rating, or the discharge rating, and this example here is a 60C battery, and this is a 75C battery in the photo. So what is mean by the discharge rating and how it is important for us? So it's a simple formula. it tells what is the maximum current you can draw from a battery. So in a simple formula, maximum current draw equal to capacity into C rating. So for example, I have a 100 milliamp hour battery, and it has a 100 C discharge rating. So if I 1000 mAh means 1 Ah. So 1000 divided by 1000 equal to 1 into 100 is equal to 100 amp. So this battery can supply 100 amps maximum. You cannot go beyond 100 amp before destroying the battery. So 100 amp is quite much ampere, but when we talk about drone in racing and freestyle, you need a lot of amps. So at one point I have seen myself using more than 90 amperes at a time. So yes, go for a battery with higher discharge rate. 75 C discharge rate is always preferred than 60 C discharge rate. So you could be asking me that why cannot we go with a battery with very high capacity and very high discharge rates? Because more the capacity, more flight time you will get. But then I'll tell you, everything in this drone is about finding that sweet spot, and nothing comes free without trade-offs. And what is the trade-off here is, more the capacity your battery has, more the C rating your battery has, more fat it becomes, more weight it has, and of course it is gonna be more heavy, and it will increase the overall weight of your drone, and it may give you more flight time, but it may also be adding more weight, because of which you will getting less RPM and less pleasant flight experience, and overall less flight time. So again, finding a sweet spot. So talking about FPV drone racing, these are the batteries which we generally fly. For a 5-inch drone, I am flying 1300 mAh 4 cell 100C battery. So this is my 1300 mAh 100C battery. This is a 4 cell battery. That means it has 4 cell, and at full charge it gives me around 16.5 volts. So yes, that is the battery which I'm using. So yes, I want to discuss a couple of things more which I have not put in the slides. So these are the battery connectors. So this is the main battery connector which you connect with your drone, and this is the connector which is used for charging the battery. It's called the balance port. So these batteries are quite unsafe if you do not handle it well, because the lithium is flammable, and if I puncture this battery, if I crash and this battery get punctured, it will immediately catch fire. So you need to make sure to treat this battery with utmost care, because lithium is quite dangerous and flammable. And even when you are charging and discharging the battery, make sure to never discharge it beyond a certain limit. Make sure to never discharge the battery beyond 3.6 volt per cell. Otherwise the cell will be damaged forever and you cannot recover the cell. Also, when you are charging the battery, make sure each cell is charging at the same rate. So let's say this is a 4 cell battery, and 2 of my cells are charging at a higher rate and 2 cells are charging at a lower rate. This will create an imbalance and can cause fire. That is why the balance port is provided, and this port ensures that each and every cell is charged at a constant rate. And make sure to always balance charge your battery, and we'll talk about charging in the later chapters. But yes, I wanted to show you that these two connectors, and this is of course the male connector of the battery, and this is the drone where you have the female connector, and it connects together like this. So just make sure that your drone has the same connector with your battery. Otherwise, if your battery is having different connector, your drone is having different connector, they cannot be connected together. So yes, that's the one thing I wanted to discuss about the safety. And now let's talk about the connection, the very last part of this chapter. So we talked about motors, we talked about ESC, we talked about battery. So how they are connected together. So we know that motor has 3 wires. It is connected to 3 wires of ESC, and ESC is connected to the battery and connected to the flight controller. So now let's forget about the flight controller for now, and let's just see how this is connected. So motor connects to the ESC and ESC connects to the battery. That is the entire connection diagram. And because we are talking about quadcopters, we have 4 motors, we have 4 ESC, but we only have 1 battery. So we need to share the battery to all the 4 motors, and this looks quite ugly if you do by soldering and connecting all together. So that is why we use something called power distribution board. this is nothing but a small PCB. So over here I connect my battery, and on this this battery is being distributed using this PCB, and each ESC can be connected to one particular port. So this is a small component which you can use. It's called power distribution board. These days your flight controller also has a power distribution board itself, so we'll talk about that in the next chapter. But yes, so this is used for distributing the power in your drone. In case of hexacopter, you'll have 6 motors and 6 ESC. In case of octocopter, you'll have 8 motors and 8 ESCs, and so on. So this gets ugly, but you can definitely do that. You can definitely solder each other together, but that's the use of power distribution board. So just for you to see. And yes, so there are different ways to connect your motor to your ESC. So one way is there are something called bullet connectors like this. So these are the bullet connectors. So you can connect these bullet connectors to your ESC bullet connectors. But as I mentioned in the first chapter, every gram counts in case of drone, and every grams adds to the weight. So nowadays what people do is they directly solder the motor wires to this ESC. So this ESC comes naked from the manufacturer, because they know that people no longer use bullet connectors. So we directly solder this ESC. We directly solder this motor wire to this ESC to save some weight, to save some grams. So that's how the connection happens. Let me fit it into the frame. Yeah, that's how the connection happened, directly soldering it. And yes, 4 motors, 4 ESCs, and 1 battery for quadcopter. So yes, that was all for this chapter. We talked about battery, we talked about ESCs, and we talked about the motors. And I hope you get to learn something new today. And if you have any doubts, just bring it tomorrow to the office hours, and I'll try to solve that one. We have one more class to go on the part A. And yeah. That was all for today class. Thank you very much for joining, and I look forward to seeing you in the next one. Bye.